Hello, honors physics students. We're going to start today with our magnetism practice problems, looking at numbers 1 and 2. So pause the video, try both those problems completely on your own, and then come back to see some tips. Alright, so lots to unpack here in number 1, but we are just talking about the magnitude of the force. What kind of force is it? It's magnetic force because we got this moving charge in a magnetic field. We know that we have one equation, that is this one here, F sub m equals QVB sine theta. We're going to have some other equations for magnetic force. We have to make sure we're using the right one at the right time, but we'll get to those equations later on. We know we're going to use this one because we have a moving point charge. And of course, that's the charge in the equation, which of course has absolute value around it. V is its velocity, B is this external magnetic field, and then we have sine of theta. And as we've seen before earlier in the year, anytime theta is part of the equation, it always refers back to the two previous vectors. In this case, that's going to be the velocity vector and the magnetic field vector, which in this case just means, it's perpendicular, so it's going to be 90 degrees. But let's go ahead and see what the charge is. Well, it says this ion is missing 2 electrons, has a net charge of 2 elementary charges, and we already know what the elementary charge is. And if you didn't know, well, I hope you looked it up because, you're honor students. More than likely you remember it anyway, but, when it's something you don't know, don't wait for me to do it. You look it up. And so that means it has a charge of 3.2 times 10 to the 19th coulombs, because, of course, one elementary charge is 1.6 times 10 to the 19th coulombs. The velocity is given, magnetic field is given, and then the angle is 90 degrees. But wait a second, that's not this. Oh, hopefully you noticed, of course, that this is in Gauss. Otherwise, you'll look at your exponent and say, wait a second, I'm off by a lot here. Because, of course, we established the Tesla as the standard unit of the magnetic field, and 1 Tesla is equal to 10,000 Gauss. And if you didn't know, well, now you know the Tesla is the standard, and of course you see that because when you check your answer, you're off by a factor of 10,000, right? So you have to convert 9 into 50 Gauss into 0.095 Tesla. And now we should get the right answer. Look at number 2. Now we've got a beta particle, which I'm telling you is just a high-speed electron. And again, traveling at right angles, magnetic field, speed given, we want to find the acceleration. So we start with QVB sine theta. It's an electron, so we know the charge. But wait a second, you say, what about the negative sign? Sadowski, you messed up. No, I didn't, because of course there's absolute value here. So if you have a negative sign, you messed up. You can't miss these details, right? If it's an absolute value, don't put the sign on it. So here's the charge, here's the velocity, here's the magnetic field. It's a right angle, so it's 90 degrees here. And you should be getting this as the magnitude of the magnetic force on it. Everything's 2 sig figs, so we have 2 sig figs in our answer. Yes, it's not the answer to the problem, so if you carry an extra sig fig or 2, okay, but I'm really not sure why you're doing that at this point. But that's not the answer because we want the acceleration of the particle. So what equation could we possibly use to find the acceleration? No, I don't know. How about sigma F equals ma? And of course, I know that you wrote sigma F equals ma because you are Sadowski-trained honors physics students, right? Even if there's only one force, you will never write Newton's second law in any other way other than sigma F equals ma. And I have faith, of course, that you did that. We're going to rearrange for acceleration as sigma F over m. And here I've immediately replaced sigma F with F sub m. And so I guess if you wrote F sub m equals ma, I'll allow it because you don't write to the idea there's only one force acting on it, but that's, a dangerous pitfall to fall into. We don't want to do that. We always want to write sigma F equals ma to account for the fact that maybe there are multiple forces acting on it. But you know what? Just like the electrostatic force, the magnetic force will dwarf any gravitational effects. So unless the problem really specifically tells you to deal with anything with gravitation, you can pretty much just neglect it. And so here we're dealing with only one force, so it's a magnetic force. And what mass are we going to use? Oh, well, I told you it's an electron, so you know what? We know the mass of an electron. Now, maybe that's something that you don't have off the top of your head, although, we did it quite a lot, so there's a really good chance you do remember that off the top of your head, but if you don't, you look it up, right? That's what you do, because you're honor students. And so we put the numbers in, and we should have no problem getting this as the acceleration of this beta particle.